All right, so in this video, I'm going to talk about something called the distributive property. Okay, now the first thing I want you to notice here, I've got 3 and then a bracket and then x minus 2 and then another bracket. So I've got some things going on inside a set of brackets and I've got a number sitting out front of that set of brackets. Now, I didn't write down any operation outside of the brackets, and that's because whenever we have a number or an integer that is next to a set of brackets, what we are really doing is multiplying. Now, I don't want to write that x for multiplying because x is quite often my variable. So what we do whenever we have a number that is right next to the end of a bracket like this, it does mean multiplication, but we are just not going to write that multiplication sign. We are going to take it as implicit. So if I don't mean multiplication, I need to be very specific about what other thing it is supposed to be. Okay, so this is a multiplication statement. Now you might remember from a long time ago, when we were multiplying, we always looked at it as saying it is a certain number of groups and then how much is in each group. And that's really what we're doing here as well. So what I'm going to do is I'm going to think of this 3 as saying 3 groups. Okay, and inside each group is what I have in the set of brackets. Okay, so I've got 3 groups, and then this tells me, I don't know how to write the word what. That H is not working. Okay, so there we go. We got what is in each group. Okay, so that's kind of what we're looking at doing with the distributive property, is it is just multiplication, but what we are putting inside each group is not just a single number, it's a combination of things. So it's kind of like I'm taking an expression and I've got different terms inside of it, and I'm going to make 3 groups of that exact same expression. So here's what it would look like. Right? If I want 3 groups of something, I'm just going to write 1, 2, 3 so I can kind of see the different groupings that I'm looking at. And what I'm going to do is inside each group, I'm going to put an X and 2 -1 tiles. I'm going to use those same tiles that we've been using. So X is represented by these green rectangles. So if I need a group, my first group needs to have an X in it, and it also needs to have 2 -1s in it. So that means I need 2 of those white squares, right? Now my second group needs to have the exact same thing. This multiplication says I need 3 groups where each group has the same stuff inside of it. Okay, so everything in the brackets there is the stuff that is in each group. So my second group has an X tile and 2 -1s, and then my third group also has its own X tile and 2 -1s. And when you look, I now have 3 groups, so I could put circles around, or I guess ovals. I could oval around them, and I have the same amount of stuff inside each group. Each group has an X in it, and each group has 2 -1s. Now when I write it all like that, everything all together, all of this stuff all together, means I have 3 X's in total, and I also have 6 -1s in total, right? So using my distributive property, I can take 3 times, and then in brackets we had x minus 2, and that becomes 3x minus 6. Now I hope you can kind of see where this is going to go in our next video, but I'm just going to focus on using the models in this one, okay? Let's look at the next one. So it says model 4 times x plus 3. So that means, again, the 4 in front tells me I need to have 4 groups. All right, so I'm going to look at setting up 4 lines, 4 groups, 1, 2, 3, 4 groups. Okay, now each group should contain inside of it an X as well as 3 1s. So there are different things that are going inside of these groups, right? I'm not putting the same tile in one single group. Each group is made up of different things, but each group will be made up of the exact same thing as the group before it. So if each group needs an X, I'm going to draw an X in every single line or in every single group. And now I need to draw in my 1s. So it says that it's plus 3, so that means I need to have 3 of these red 1s in that first group. I'm also going to need 3 red 1s in every other group. And through some quick video magic, you can see that each group now has an X in it, as well as 3 1s. Each group contains an X, and it contains that positive 3. So as I oval around each group, I have 4 groups that have exactly the same thing inside of each group. And I can see that all together, when I look at all of my stuff in the groups all together, I have 4 X's all sitting there. So I have 4X. And then here I have 12 1s when you count them all up, right? I've got 4 groups of 3, so that means I've got 4x plus 12. Okay, so this is using our distributive property to help us figure out how many groups we have. Now I'm going to do the same thing here. Okay, I've got now, negative 2. Negative 2 groups. Oh, that's weird. Okay, negative 2 groups. Okay, I'm just going to start by doing my 2 groups, okay, just to see what happens. I'm going to do my 2 groups first, and then we'll see if there's any repercussions or anything else we got to do after that. Inside each group is an X and 3 negative 1s, okay? So let's get our X in each group. So there's 1 for the first one and 1 for the second one. Okay, and then we need our 3 negative 1s here. So 1, 2, and 3. Okay, and then 1, 2, and 3. And I apologize, you can tell that my hand is tired because my drawings are getting worse and worse. Okay, here we go. Oh yeah, that definitely did not help, and I probably made it worse. Okay, goodness. All right, in each group, I've got an X, and I've got my 3 1s, but they're negative, so they're not colored in, they're white. Okay, so I've got X minus 3 in each group. However, we said that it needs to be negative 2 groups. And so what I want you to think of with a negative, whenever we've got a negative, the negative is really telling us to flip our signs. So if you think of what we've done with the other models, is we've always taken our X and we've flipped it from one color to the other color. And then we have to flip the other side equally. So this, we're going to draw out 2 groups, but then we have to flip our groups. And so if you had these tiles sitting in your classroom and we were playing with them, I would tell you to physically flip over your rectangles from their green side to their white side, because the negative sign tells us to flip our sign or change our sign to its opposite. So I'm just flipping all my tiles upside down. So the little white squares are going to flip from being on their white side, they flip over to being on their red side. So I start out the exact same way. I draw the number of groups that I need, or the number of rows I'm going to use. I put the right amount of things in each group, and then I simply just flip all my tiles over to their opposite colors. Now when I look at everything all together, now I have 2 X's, right? I have 2 X's, but they're negative, so I put that negative in front. And then I have 6 1s, and these 1s are positive, so I write it as positive 6. Okay, and this is just using our distributive property. It tells me how many groups, how much is in each group. Okay, one last one. Now this is beyond the scope of grade 8. Okay, this is too hard for grade 8 students. So, I mean, you might not be able to get it. And if you can't, I'm sorry. You'll just have to figure it out when you're in grade 9. Now, same thing. I've got 3 groups. 1, 2, 3 groups. Inside each group now, it's a little bit different. I need to have 2 X's. Oh, that's weird. We've never had 2 X's in a group. We've always had 1. Oh well, hopefully our model will still work. And even though this is beyond the level of what grade 8s are supposed to be able to handle, I wonder if you guys can do it. So I'm going to put 2 X's into each group. Okay. And once I've got my 2 X's in each group, I'm now going to say I need negative 1 in each group. So I got to put in a white square into each group here. All right. So 3 groups. Each group has 2 X's and a negative 1, right? 2 X's and a negative 1. 2 X's and a negative 1. 2 X's and a negative 1. Well, when I draw it all out like that, I've got my 3 groups. Well, all together, there are 6 x's that I wrote down. And altogether, there are 3 negative 1s that I wrote down. So I get 6x minus 3. Oh, maybe that wasn't so bad. Wonder why grade 8s aren't supposed to be able to do that. Oh well, I hope you guys understand how the distributive property works here by using the models. Next video, I'm going to show you a really fast, easy way to do it without using any drawings.